The morning of February 28th, 2017, started like many other days in AWS's Northern Virginia region. Some engineers were preparing to make a fix to the billing system. And so one of those engineers sat down to a terminal, he issued a command, and unfortunately, total chaos erupted. The official statement from AWS says this: unfortunately, one of the input commands was entered incorrectly, and a larger set of servers was removed than intended. As a result, some key servers were taken offline, the ones that control the get, list, and put and delete from S3, as well as the placement subsystem that controls where data gets stored. And so all these services that rely on AWS's S3 service in the US East 1 region went offline. And all these customers were impacted in one way or another. Perhaps the most embarrassing impacted was AWS themselves. And the dashboard, the health check dashboard that they used to communicate uptime, was broken as well because of the S3 issue. So S3's stated availability goal is 99.99%. And that leaves us with about maybe 52 minutes per year of disruption. Unfortunately, the S3 outage on February 28, 2017 took 252 minutes. And so the point here is that despite advertising availability goals, there's always a chance that something like human error will conspire to exceed these goals. And in fact, Werner Vogels, the Amazon CTO, says very famously, everything fails all the time. So therefore, we need to architect for everything to fail. Here's some terms that we're going to baseline everybody on. First, business continuity and disaster recovery. These are two different things. Business continuity seeks to minimize the business activity disruption when and if something happens. Now, disaster recovery, on the other hand, is the act of responding to these events that threaten business continuity. So what's the difference between fault tolerance and high availability? There is some debate, and people tend to use them interchangeably. I like to think, though, that fault tolerance is literally the ability to tolerate faults, meaning if any problem happens, my users don't even know that it happened. But that's very expensive and sometimes cost prohibitive. High availability, on the other hand, leaves some room for unplanned downtime, as highly available doesn't mean always available, no matter what. I also want to clarify what's meant by a service level. It's usually some form of agreement or commitment for quality or availability or responsiveness, but it does not mean a guarantee. Sometimes service level agreements have consequences if the service provider fails to meet the SLA. And in the case of AWS, some services have specific SLAs and offer service credits in return if they fail to meet those commitments. But you're responsible for proving that downtime and making the service credit request. You're not going to have to know these service credit figures for the exam, but I'm just introducing it here as there's a lot of people that are unaware that AWS's standard SLAs have remuneration provisions. Two terms you're going to hear a lot about in high availability and disaster recovery conversations is recovery time objective and recovery point objective. Now, recovery time objective is just the time that it takes after a disruption happens to restore business processes to their service levels. And recovery point objective is the acceptable amount of data loss that's measured in time. And how I keep these straight in my mind is RTO, T is for time, and RPO, P is for the data that goes poof. Here's what it looks like in a more graphical fashion. So let's say we're taking backups regularly, and then we have some sort of disaster. Now, the amount of time between the disaster happening to we're fully recovered is RTO. Now, because our last backup was sometime before the disaster, we're probably going to lose an amount of data. That's RPO. Most companies start with a business continuity plan, and that usually defines acceptable RPO and RTO objectives. And the RTO and RPO have to support the business continuity plan because the authors of the BC plan have to have certain assumptions for how long services are going to be unavailable or how much data gets lost. Now, the RTO and RPO then justify the level of high availability investment we want to make. And they also define what our process is for disaster recovery, because ultimately high availability is going to try to mitigate the act of having to do a disaster recovery. But if we do have to do the disaster recovery, it's going to deliver or fulfill those RTO and RPO objectives. Okay, let's look at some types of disasters. And really, this is more so just to get you thinking about all the different things that can go wrong. So first, we have hardware failure. I think everybody probably can relate to that. Maybe a network power switch fails and brings down the LAN. That's why we oftentimes in local area networking, we have redundant cores. Maybe there's a deployment failure. We go to install a patch that breaks a key ERP business process. That's a bad thing. Maybe a disaster is load induced, and examples of this are DDoS attacks on your website. Maybe the problem is data induced. An example of this is the Ariane 5 rocket explosion on June 4th, 1996. And in that case, the Ariane 5 rocket control software suffered a catastrophic failure when it was trying to do a data conversion from a 64-bit floating point value into a 16-bit signed integer. And that caused the onboard processor to go out of control and initiate a self-destruct sequence. Maybe there's a credential expiration. And occasionally you'll see this on e-commerce sites where somebody forgets to renew the certificate and you get that scary message saying that this site could be inauthentic. Another good reason to use Certificate Manager. Maybe there's a dependency disaster. The S3 subsystem failure was a good example of this dependency failure because it cascaded to many other AWS services. Maybe there's an infrastructure disaster. Let's say a construction crew out in front of your office accidentally cuts a fiber optic data line. Maybe there's an identifier exhaustion. Occasionally you'll see this on AWS where they'll just simply run out of capacity in a certain AZ for an instance type that you're requesting. And if you have an auto scaling group that's set up for a certain type of instance and they simply don't have capacity, that could cause some big problems. And then finally, there's always human error. Oh, I thought I was in the QA system. Or various other crazy commands that people have been known to type in.